Assalamu alaikum. Pardon me. Assalamu alaikum wa rahmatullahi wa barakatuh. So yes, so on with the topical past papers. I know you didn't do enough last time, so let's just do until we can say we have done enough. Now, this is obviously case 3. And how are you going to identify the case? The very first thing is you look at the question, you see whether the mantissa and exponent have been given to you, or you have to find them yourself, right? If they have been given to you, then you know it's either case 1 or case 2, right? And if, the leftmost bit or the least significant bit is not 1, it is 0, which means the binary number is positive, it's case 1. Had it been negative, it would have been case 2. This was our case identification. Okay. And yes, in case you're wondering about which question it is, sorry, which paper it is, this is the variant. Okay. See for yourself. Now look. So numbers are stored in a computer system using binary float point representation with 10 bits for the mantissa, 6 bits for the exponent, and 2's complement for both of them. Okay. So all of this is not most of the time necessarily necessary. It should be that you read it, because I mean, who can guarantee that later on, they're not going to give you something different. So, but most of the time it is the same. It doesn't mean you shouldn't read it, you should. But as of now, we don't really need to do it. So case 1, how do we solve it? So the very first thing we do here is this. We write it all down, right? 0, there are 4 ones, right? 1, 1, 1, 1. You know what? I was thinking about something. Instead of rewriting, let's just do it over here, right? Okay, so now look, I do have my calculator on. Yes. By the way, the calculator is not allowed in the exam. I'm a teacher, so I can use it, okay? So the very first thing is you have to decide where the decimal point is going to be, and I told you that it has to be on the least right before the least. Sorry, it has to be right before the least significant one. It has to be right before the least significant one, right? Over here. Now let's say in case this was 1, if it had been 1, you would have said then it should have been here, right? But that is not the case. It's more like, it's before the least significant bit. Or in other words, you can say for the positive binary numbers, it is after the least significant one, right? But mostly it's just over here, before the least significant bit. So we found ourselves what? Our decimal point. That was step 1. We're done with finding the um the decimal point, right? Now we need to know how many boxes are we supposed to move it to the right or to the left, right? And we know that the exponent is positive. Why? Because this is a 0, this is not a 1, so we know that our exponent is positive. And if your exponent is positive, this goes to the right. How many places? We're just going to calculate our exponent now. So this is 1, 2, 4, 8. You don't really have to go any further. Why? Because there's zeros anyway. So 8 plus 2 plus 1, 8 plus 2 plus 1 gives you 8, 9, 10, 11. Yes, my maths is pretty bad. So I've been teaching maths though. Never mind. 8 plus 2, 8, 9, 10, 11. Yes. So now you have to move it 11 places to the right, right? So it has to be, okay. Now look, this is where things get interesting. This is where things get interesting. You don't have enough places, right? Like for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are no the 10th or 11 bits, right? Then what is it that you do? You place extra zeros over there, right? You place extra 0. Now, and in order to do that, it would be better if I was to write it down. So I am going to do so. 0, 1, 1, 1, 1, 4 zeros, 0, 1, 0, 1, right? And then a couple of more zeros. This is where the decimal point is, right? And then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So this is where it goes. So we know that our fractional part is going to be 0. Why? Because these are zeros. However, this is 1, 2, 4, 8, 6, never mind, 16, 32, 64, 128, and then a couple of more new ones, right? Because you don't usually go till here. It's 256, and then it's 40 something. I've forgotten a bit. You know what? This is very embarrassing as a teacher, but I am still going to do it. 256, 2 raised to the power 9 is 512, right? Never mind. It is 512. And then 1024. You should have memorized it till here. You really should have memorized it till here. Okay? And once you have all of that, now you know everything that you need to add, right? So I'm just going to add it up pretty quickly. Okay, so I just made a mistake. I said this was case one. This is not case one. This is case three. I'm sorry. I'm really sorry. Okay, but never mind. You shouldn't be trying to memorize it. With the numbers of the cases. But you should instead be trying to say, okay, how do you try to convert from positive binary to denary, or positive denary to binary, or negative like this, right? I just, named it case one or three just for convenience, right? But if it tries to confuse you, you wanted to memorize that, okay? And yes, I did say that the numbers aren't going to be this big. They might. I said, never mind. They might be sometimes, right? Just like over here, we have got 1024 and 512. It may happen, right? So you should have it memorized, right? Even to 2 raised to the power 11, just in case, or just to be, you know, be resilient to the Cambridge questions. If you want to know what comes after it, after 1024, it's 2048, right? And then you have 4096. So do remember these two, because I mean, you're in A levels, you should, right? But over here, we don't really need it. I did say one thing, that this part, this decimal part, this fractional part is not going to be way too big, right? But this other part, this integer side, can be this big, right? So I'm going to do the rest of the working over here, okay? So it's 1024 plus 512 plus 128 plus 16 and plus 4. That entire thing gives you 1940, I think. Let me just recheck. It is 1940. Okay. So that is your answer. And yes, I did make a little mistake over here as well. There were two zeros in here, right? So after the four ones, you've got double zero. So, I mean, let's just shift all of it to one side, right? This is going to be two zeros, and then one. It has to be 0, 0, 0, 0, right? And then a one, and then a zero, and then a one. And then you can put zeros, right? This is what it was. Like, I just shifted this over here. This is why it's not an 8, it's a 4. So you've got 4 plus 16 plus 128 plus 256 plus 512 and plus 1024. This is your answer, right? And it would be better if you were to write it this way, because you have to make sure, you have to tell the examiner that, this fractional part is 0. So you did try to calculate it, but it equates to 0. Honestly, you don't really have to do it, because in the marking scheme they didn't do it, but, just so that you can be sure, just so that you can be sure of the fact that this part exists, it's just that it equals to 0, right? Now look, normalized normalized binary floating point representation of this. Now this is case one, right? Positive binary to binary. Okay. So like I said, we're just going to pretend like the fractional part does not exist, and we're going to try to focus on 26, right? So let's do it this way. 32, 16, 8, 4, 2, 1. Okay, and then a 0, and then you've got the rest of them: 0 0.5, 0 0.25, 0 0.125, 0 0.06, 125, 125, right? And 0 0.0312. 5. Never mind. So we know 32 is greater than 26. So obviously that is not going to be the case. But 16 plus 8 is what? That's 24, right? So 16 plus 8 is 24. And now we just need two more to make it 26. So over here. So 16 plus 8 plus 2 gives you a 26. 16 plus 8 plus 2 gives you a 26. That is how you get it, right? Now, how about 0.6875? 0.6875, right? Now, first of all, there's the hidden trial method and there's the other method I talked about in my last video, right? Let's try to do the hidden trial method because I feel like I can do it. We can do it this way. It's going to be 0.5 plus 0.125, right? So it has to be 0.1625, right? I think we are close enough. Yep, I think we are close enough. So now that, what if we add 0.06125 in it? Nah, that is not going to be the case. Just give me another second. I made a mistake. Guys, we found ourselves the answer. By the way, this wasn't 0.06125, it was 0.0625, right? This is where the 1 to 5 is. I used to get confused with it, but the only way to memorize, not the only way, but a way to memorize it would be remember that the 1 to 5 appears with the 3 and with the 6 there's only 2 5, right? So we've got ourselves an answer finally. 0.5 and then 0.125, right? And then this is the only one remaining. So this is going to be a 0.625 plus 0.0625. And this entire thing gives you 0.685675. 0.68756875. We got ourselves the answer, right? So it is 1011 and then another zero. This is what it was. Now comes the normalization part. We already talked about what normalization is, and that is you take it to the least significant part. That would be a before the least significant bit, and that's going to be Bismillah 1, 2, 3, 4, 5, right? And that gives you 0.11010101, right? Let's just do it again. 1101011. There's no harm in making sure, right? And yes, how many places did we move it? One, two, three, four, five. 5 places, right? So what is the exponent going to be? We already found the mantissa, right? And obviously we have to write it from left to right. So let's just start writing it. That would be 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, right? The exponent here is 5, so that's going to be 8, 4, 2, 1. 5 would just be this, right? So 1, 0, 1, 0, and then the rest of them are zeros. Here you've got yourself an answer. It was simple. Now look, the entire concept is simple, but even I, as a teacher, can sometimes make mistakes. Sometimes I forget things, right? So remember to recheck your paper every time you're done with it. Every time, whenever you're doing topicals and whatnot, do not try to use a calculator for now, okay? Because I use it because I want you to make sure I'm not going to waste any of your time. I'm a bit slow when I'm summing stuff up, so I would rather not waste your time and make more silly mistakes, on top of the ones I've already been making. So that's it. Inshallah ta'ala, I'm going to see you in the next one.